Hi, hello, vanakkam, and welcome back to yet another episode on Little's Law YouTube channel. So, today in this video, we are going to see about one of the most powerful concept or powerful rule that is used in performance engineering or testing, which is the Universal Scalability Law. So, we will see how to use this Universal Scalability Law to predict and optimize the system scalability. So before we move on to this video, I will take you through an example of a retail store. So how does a retail store works and how does the point of sales system can be best utilized by using this universal scalability law. And then I will correlate the same with a perfect example in performance engineering, and then I will explain you what is universal scalability law, how does it work, and what are all the concepts that are involved in universal scalability law, their advantages and their limitations. So first let's see an example. So imagine you are a retail store owner and your point of sale system is critical for your business. As the number of customers and transactions increase, you want to ensure that your system can handle the growing workload. And that's where the universal scalability law comes into play. So, the universal scalability law is a powerful concept in performance engineering that helps us predict and optimize the system scalability. So here we will take the example of the POS system, that's the point of sales system, to understand how it works. So in our scenario, the initial performance test of the POS system showed that it could handle 50 transactions per minute with 5 cashiers at the point of sales. But how will it perform as we add more cashiers to meet growing customer demand? So we are going to see how are we going to meet the customer demands by adding more cashiers. So the law considers three key factors. One is the throughput, the second one is contention, and the third one is coherence. So let me explain you about these three concepts, that is throughput, the contention and the coherence. So throughput represents the number of transactions the system can handle in a given time period. So in our example, the initial throughput is 50 transactions per minute with 5 cashiers. And next comes the contention. So contention can arise when multiple cashiers compete for shared resources in the system. So for example, like it can be a database access and it can be a network access. So as we increase the number of cashiers, the contention for these shared resources might impact the system's performance. So the universal scalability law can help us to analyze the impact of the contention on scalability. And next, the last one comes the coherence. So the coherence refers to the law of communication, the level of communication and synchronization required between different components in a system. So in this POS system example, as we add more cashiers, there might be an increased need for coordination. They have to communicate among themselves and they have to be synchronized among different components, such as we have the inventory management system, we have the payment processing, and then we have other order fulfillment. So the universal scalability law should provide insights into how the concurrency affects systems scalability, and that's where we apply the universal scalability law to this example. So the formula is S of n equals n divided by 1 plus again the n minus 1, and then we have the alpha plus n multiplied by b. So what are all these? What is s of n, or what is n, or what is alpha, or what is beta? So the s of n represents the scalability of the system when using the n number of resources. So it indicates how the system's performance scales as the number of resources. So in this case, the number of cashiers, for our examples, in this case, we have the number of cashiers in our system. So the value of S of n gives us an indication of how efficiently the system handles the workload as more resources are added to the system. And next we have the n. So this variable represents the number of resources. So in the example, it corresponds to the number of cashiers in the POS system, and it is the input value that we want to assess the scalability for. So for example, if we have 5 cashiers initially and we want to predict the scalability with 15 cashiers, so n would be 15 in this equation. And next comes the alpha. So this coefficient captures the impact of contention on the system scalability, and this quantifies the extent to which the contention affects the performance as more resources are added. So the specific value of alpha is determined based on analysis and historical data of the system, and this represents the system's behavior under contention. And finally, we have the beta. So this beta coefficient represents the impact of coherence on scalability, and this captures the additional communication and synchronization overhead required as more resources are added. So like alpha, the value of beta is determined through analysis and historical data of the system, representing the system's behavior regarding coherence. So when using this equation, the we can input the specific value of n, that is the number of resources we want to assess scalability for, along with the determined coefficient alpha and beta into the equation. So the resulting s of n value indicates the expected scalability of the system with the given number of resources, considering the contention and coherence. So what do we get by analyzing the s of n? So when we analyze how the S of n changes as the n increases, so we can gain an insight into the system's scalability behavior and make informed decisions regarding the resource allocation, their optimization efforts, and the performance improvements. So far we saw about how to use or where to use the values. I have told you about what is n, what is alpha and beta. So let's say we add 10 more cashiers, making it a total of 15 cashiers. Plugging in the numbers, the law indicates the system scalability with 15 cashiers is expected to be around 1.97 times the initial performance. So this means that as we add more cashiers, the system's performance improves, but not in a perfectly linear manner. So the factors like contention and coherence may affect the scalability, as we have already discussed about what is contention and coherence. So they may affect the scalability. So how can we optimize the system? So how can we? So we have found the system, we have found the numbers, we have found all the values, and we even have the formula. So how are we going to optimize the system? So we can focus on reducing the contention by optimizing the database access, by improving the communication protocols, or by implementing load balancing techniques. So these optimizations will enhance the scalability, allowing our POS system to handle the increasing workload efficiently. So in conclusion, the universal scalability law empowers us to understand, can help us to predict and optimize the performance of systems like our POS system. So, by leveraging this law, we can ensure that our system scales smoothly as our business grows, providing a seamless and efficient experience for both us and the customer. So, now we will see how to use or what exactly is this universal scalability law. So far, we saw an example, the POS example, the point of sale. So now we will see what is universal scalability law. So universal scalability law is used in performance engineering widely. So we all have used the universal scalability law. So why do we use it? So the first point is to understand the system. So what does it mean by understanding the system? So it is to predict the scalability of the system, Also, it helps us to analyze how the performance of a system changes as we increase the resources, such as the number of processes or the amount of memory. So that's why we use the universal scalability law. So this law can be applied in performance testing to assess the scalability, their performance characteristics. So what are the areas where it can be useful? So the first point is in the capacity planning. So when planning for a system capacity, it is essential to understand how the system will perform as the workload increases. So we saw that in our example, in our previous example. So we saw how does the system will perform when the workload increases. So by applying this universal scalability law, the performance testers can predict how the system will scale with additional resources and identify for any potential bottlenecks or limitations, because identifying the bottlenecks or limitations is our primary objective. So this universal scalability law helps us to identify the bottlenecks or any limitations, and the information helps us in determining the optimal configuration and the resource allocation to meet performance requirements. And next comes the performance analysis. So during performance testing, this law can be used to analyze the behavior of system under different load conditions. So when it comes to performance analysis or during performance testing, the universal scalability law can be used to analyze the behavior of the system under different load conditions. And by collecting the performance metrics and inputting them into the scalability formula, so which we already saw in our example. So by inputting those values into the scalability formula, the testers, the performance engineers can evaluate how the system's throughput, its contention, and coherence affects its scalability. And this analysis helps us in identifying the factors that limit performance and guides optimization efforts. And third comes the resource optimization. So while we do performance testing, we often involve in identifying and optimizing the resource utilization to improve the system performance, because that is what we need so to improve the system performance. And the universal scalability law can guide this optimization process. So how does it do, or how does it do that? So it provides insights into the impact of contention and coherence on scalability. So the testers can analyze how changes in resource allocation or tuning parameters affect the scalability formula to find the most efficient configuration. And finally, it comes the workload modeling. So workload modeling is an important aspect of performance testing, and we all know that, where testers simulate realistic usage patterns to evaluate the system performance. So the universal scalability law aids us in workload modeling by helping the testers understand how different types and intensities of workloads impact scalability. So the performance engineers can use the formula to estimate how the system will handle varying workloads and make informed decisions about the required resources. So this universal scalability law, also known as USL, is a mathematical formula that helps analyze and predict the scalability of the system as the resources are added, and this provides insights into how system performance changes as the workload increase or additional resources are allocated. So to explain the universal scalability law with a real time example, let's consider how a web application that handles a user request can be s- analyzed. So, the performance of this application depends on factors such as the number of concurrent users, the server's processing power, and the efficiency of the application code. So, let's say we want to predict the application's performance with 200 users using the universal scalability law. Using the universal scalability law formula, which is S of n is equals to n divided by 1 plus n minus 1 multiplied by alpha plus n multiplied by beta. So here the S of n represents the expected scalability and n is the number of concurrent users. So by plugging in the value, we get the following equation. So the result approximately is 1.65, which indicates that the expected scalability of the application with 200 concurrent users is 1.65 times the initial performance. And by interpreting this result, we can understand that the application's performance is scaling reasonably well with the increased workload. However, it also suggests that the scalability is not perfectly linear. So, in fact, even we saw the same number in our previous POS example. So, the scalability is not perfectly linear, and there might be factors like contention or coherence starting to impact the performance. So based on this analysis, the development or performance engineering team can make informed decisions, and they might even consider optimizing the code, tuning the server parameters, or by adapting load balancing techniques to improve the system's scalability and ensure efficient performance as the workload increases. So now, before we close on, we will see the advantages of using the law and these limitations of using this law. So let's now quickly see the advantages of using this law. So the first one is scalability prediction. So this law predicts how a system will scale with additional resources or increased workload, and it provides insights into expected performance, aiding in capacity planning and resource allocation. And the second point is the performance optimization, whereby identifying the bottlenecks and areas for optimization, the law guides us in the performance improvements, and it optimizes resource utilization, addresses contention and coherence issues, and enhances overall system performance. And next comes the efficient resource utilization, where the law enables efficient allocation of resources by understanding their impact on scalability, and it prevents over provisioning or underutilization, leading to cost savings and effective resource management. And next comes the workload modeling, where the law supports realistic workload modeling during performance testing, and it helps to create accurate models that simulate real world scenarios, enabling effective stress testing and performance evaluation. And finally, the last advantage is data driven decision making, and this provides a quantitative basis for decision making, and it allows for systematic analysis of system scalability and facilitates informed decisions regarding the system design, optimization strategies, and resource allocation. So these are the major advantages of using the universal scalability law. So let's now move on to the limitations. So when it comes to the limitations, we have the simplified model, where the law provides a simplified model that assumes linearity and may not capture all the complexities and non-linear relationships of real world systems. And next comes the limited scope, where the law focuses on factors like throughput, the contention, and coherence, but may not consider other performance aspects such as the disk output, input output, or the network latency. And then third comes the coefficient determination, where determining accurate values for alpha and beta requires analysis and estimation and may not capture all the nuances of a specific system. So that's where we have got uh, the values of alpha and beta, but we do require lot of analysis and estimation. So without that, we might not be able to come, or we might not be able to arrive at the value for alpha and beta, which is the contention and cohesion. And next comes the sensitivity to quality, data quality. So when it comes to sensitivity to data quality, this the accuracy again plays a part. So the accuracy is sensitive to the quality and accuracy of the input data used for analysis. And next comes the lack of contextual factors, where the law does not explicitly consider contextual factors specific to individual systems, such as, for example, the hardware configuration or the software frameworks. And next comes the dynamic nature. So The law provides a static analysis and may not account for the dynamic variations in scalability that can occur due to the changing workloads or system configuration. So, with that, we have come to the end. So far we saw about a real world example of how to use the universal scalability law, and then we saw that what is a universal scalability law, and we saw an example about with a web application, and finally we saw about the advantages and limitations. So with that we come to an end. If you like this video, please subscribe to our channel, like, comment, and share the video with your friends. So until I meet you in another interesting video, it's bye bye from Vasan Shanmugam and Little's Law.